Hello, my name is Sergio Feitosa and I am the author and presenter of this training, Design Concepts for Electric Panels, Switchgear, Bus Ducts and Substations. This training was made with a focus in designers of equipment and substation equipment. It is composed of a group of video classes that we hope that cover most of the disciplines which are necessary in the daily life of a designer. We hope that it is useful for you. 12 technical standards for low voltage switchgear and control gear. IEC 61439 and IEC TR 61641. IEC 61439 is an evolution of IEC 6439. In this video, we'll give some of the main approaches specified in IEC 61439 that permit some tests to be replaced by calculation and even not to test, declared within a study. This is under the concept of design rules. In IEC 6049, the tests replaceable by calculation were temperature rise tests and short time current tests. In IEC 61439, the wording testing is replaced by design verification. And this is the new thing. This can be done by tests, as before, by designing rules, and this is new, and by calculations or simulations, in some cases where designing rules do not apply completely. We'll show here also how to use designing rules to avoid onerous tests, and related to internal arc tests in low voltage switchgear. Internal arc tests are not type tests, but they are becoming a must in the market because most of the panels users are requesting it. IEC TR 61641 give guidance on how to perform the internal arc test, how to accessibility for personal protection, restricting damage to part of the assembly, and if assembly is suitable for limited further services. These are the three classifications which are used for internal arc tests in IEC TR 61641. The link in the top of this page, you may find several very good documents, very complete documents, and free documents. Most of them are free, applicable for substation equipment, for switchgear, for many aspects, and there are also some references to good SIGRE documents that, of course, are not included here, but we have the address to follow for the ones that would acquire it in the SIGRE site. Said before, IEC 61439 is a series of standards which are an evolution of the previous IEC 60439. The most important change of concept which appeared here is the concept of designing rules. That is, if you have tested one equipment that we will call here the first of a series or the head of a family was type tested in a testing laboratory, if you follow some rules that are specified in the standards, then you may avoid that test by doing declarations, as it will be explained in the complete document and in some slides more ahead here. This series of standards 61439 in the very beginning, in 2009, were composed of 6149-1, -2, -3, 4, 5, and 6, as listed here in this slide, and the ones with more interest for us were at that time the -1 and -2, which are mostly applicable to our so-called low voltage switchgear, our main low voltage panels. IEC 61439, some concepts were included, and the first one was that it stopped with discrimination between the terms TTA, type tested assembly, and PTTA, partially type tested assembly, which was used in the series 60439. The approach, these names, which were not happy names because they gave the impression that PTTA was something worse than TTA, was replaced by the approach verification. The word tested was replaced by verified, and this is one important approach for low voltage switchgear standards, and now also for high voltage switchgear standards, especially the ones for switchgear and control gear, where we now have this approach given an opening to avoid a lot of expensive tests in equipment just by using things like design rules, calculations, and simulations. The design verification, as included in 61439, can be done by applying one or more of the following alternative and equivalent. You see here, alternative and equivalent. We are not saying that one is better than the other. All of them can be used. And these three approaches are the calculation and measurements, in certain cases, as explained in the standards, the validation of design rules, and this is based on the existence of one, let's say, first of a series, of a head of a family, low voltage switchgear, which was completely type test, and after this, based on design rules, we can avoid testing others which are quite similar but not exactly equal to the one which was tested. And another design verification method is to use the previous laboratory tests. We have the so-called design rules. This was the important concept added to IEC 61439. It's a concept in the direction of avoiding the repetition of tests. As said before, the idea is that when you test one first equipment that we will call the head of the family, the first of a series, some manufacturer tests these equipment according to all of the type tests of IEC 6149, and suppose that the equipment is fully approved, and there are several test reports witnessing this aspect of being tested and being approved. Then you have some other equipment that are basically of the same family. They are of the same construction. They follow certain rules that can be checked in this table here. The idea is that if the other equipment that may have some modifications related to the test one, if you are approved, let's say in this way, in these 10 rules, if you say yes to all these requirements, no further verification is required. That is, you don't need to test anything more, or to test or to calculate. It is as the other equipment, the not tested one, was fully tested. If you have an answer no to any one of these requirements, then a further verification is required, and this it is explained in in the IEC standards how we can do this verification. This can be done by calculations, by measurements. There are several possibilities depending on the design rule in which there was, let's say, a failure to attend the rule. As an example of the rules, the two first ones are very easy to help us to understand the concepts involved. Suppose that then that you test the one equipment and you ask for the one which was not tested. Is the short circuit withstand rating of each circuit of the assembly or the assessed less than or equal than of the reference design? That is the short circuit current lower or equal to the one which was tested? Then if your answer is yes, you are a candidate to follow all the rules. A second one, is the cross-sectional dimension of the bus bars and connections of each circuit to be assessed greater than or equal to those of the reference design? Okay, if you are greater or equal, then we can assume in the first instance that let's say the temperature rise will be lower. We can assess that, we can estimate that the supportability to short circuits of this equipment is higher than one, or at least is not lower than the one that was tested, and so on. The third rule, is the spacing of the bus bars and connections of each circuit of the assembly to be assessed greater than or equal to those of the reference design? If the answer is yes, this means in a first approach that the equipment, when it is subjected to a short circuit, the electrodynamic forces which will occur in it will be lower than the ones that occurred in the tested equipment, because as bigger, as larger is the distance between phases, the lower are the forces. Are the bus bar supports of each circuit of the assembly to be assessed of the same time, shape, and material, and have the same or smaller spacing along the length of the bus bar as the reference design? Okay, it is also known that if the distance between supports is lower, maintaining all the other conditions, the forces that will act in the supports will be smaller. And in this sequence, we go one by one, checking, for example, as if the material and material properties of the conductors of these circuits are the same. Let me see another one. If the length of the unprotected live conductors in accordance with HC4 is less than or equal to those of the reference design. If you take a look in each one of these rules, you see that it's not difficult to understand that if these rules are are attended in all these 10 items, let's say the test conditions of the equipment which was tested are worse than these ones that are included in these rules. And this is the concept of the design rules. Now, I think I mentioned this before, but there is another standard technical report from IEC, which is IEC 62771-307, in which these tables are valid for, tables like these are valid for all the tests which are in the standard, and they are written in a much more detailed way. For each test, with the explanations, with the the design parameters with the rules that should be followed. It's an evolution of this table, but in a much more complete way. In this table here, it's basically the same table of the previous slide. I added the 3 columns in the right side just to identify which kind of technical aspect is focused by the rule. You see that there are the letters T of temperature, F of force, and P of pressure. And if you look to the marks that are in the right side, you can see what each of the rules is looking for in the approach of the designing rules. Another point to call attention is that if the tests were made by the previous IEC 6439, the type tests, and you have now, the manufacturer is now thinking about, there is a new standard IEC 6149. These tests do not need to be repeated if the equipment was fully approved in the previous standard. The tests don't need to be repeated. The assembly verified by the original manufacturer and made or assembled by another manufacturer does not require that checks to be repeated. If the original manufacturer's requirement instructions were followed. This means that, let's say, one manufacturer in France, for example, he do the tests in all the type tests of IEC 6439, and then according to, or 6149, sorry, and if this manufacturing license other manufacturers all over the world to reproduce that design according to their instructions, the other manufacturers will not need to repeat all the tests. This is easy to understand and very clearly written in the standard. But checking routine shall be done in all assemblies. That is, okay, you don't need to repeat the type test, but you need to do all the routine tests in the equipment which was not type tested. Design verification according to IEC 6149-1, we need to check the equipment related to the construction and related to the performance. For construction, the basic concept of verification is to check the strength of materials and parts, the degree of protection of the enclosure, checking the creepage and sectioning distance, protection against electric shock. They are basically the same verifications that we did before in the tests prescribed in IEC 6439. Nothing changed on this aspect. The two standards, the old one and the new one, are basically in the same conception for these aspects. For performance, the tests or verifications or calculations to be done are related to the dielectric properties, the verification of temperature rise, which is a very, very important item, and should be, especially the users, should be very careful respect to the test reports issued by testing laboratories related to these aspects, because of something we explained in another part of this training, of this chapter, that is the IEC 6149 do not state clearly who are the temperature rise limits of connections, contacts, and so on. And by this reason, the testing laboratories, most of the times, I would say, do not have how to check if the equipment passed or not. Then it is extremely frequent. I would say that in the majority of the test reports that I saw up to date, that you see one report where shows the test results of the temperature rise test, but there is no statement telling that the equipment was approved or not. And many times when you read the numbers, if you follow the concepts of design, concepts which exist in the medium voltage IEC standards, you see that the limits which are there, which were reached in the test, are higher than it would be permissible for a medium voltage switchgear. Another important test, verification of short circuit withstand currents, where we will check if the equipment is able to support the very big force of short circuit. And here we are many times speaking about equipment that will be where we will have currents, short circuit currents in the order of magnitude of 65 kA, 100 kA, 8 kA, and of course all the forces involved in this kind of equipment are very severe, very strong, and this must be checked with attention. Electromagnetic compatibility is another aspect, and mechanical operation, like to check if you insert or withdraw many times a drawer, if it will remain in good state. All these verifications are very well specified in the standards. Here are some more details about the temperature rise limits for the connections in IEC 61439. We suggest you read the article indicated in the previous slide. Document IEC 62208, we have more information about how to specify entry enclosures for low voltage switchgear and control gear assemblies. These are the enclosures without the field of components. There are some manufacturers that manufacture only the enclosure, but do not mount the complete switchgear. And this standard here is good for this purpose, especially in respect to the data of thermal power dissipation capability. Let's say when you are going to buy an enclosure, you have how to know if that enclosure is able to dissipate within the parameters of this standard a certain amount of watts installed inside. Another important test is the short circuit withstand current test, in which we apply the maximum values of short circuits, which will pass through the bus bars of the equipment. And the idea here, there are two purposes in this test. One of them is to check if the bus bars are able to support the very high short circuit force that will occur inside the switchgear, because here we are speaking of levels of current around 65 kA, 8 kA, 100 kA, and in bus bars which are separated by very small distance, so the force involved are very high. We have also in another part of this short circuit test, one verification of the ability of the circuit breakers to interrupt the short circuit without passing during a long time. Let's say you applied short circuit, but in this case, instead of leaving the current to circulate, for example, for 1 second, the circuit breaker will open the circuit. You are checking then the circuit breakers. Another important verification, which is done for low voltage assemblies, is the internal arc verification. Internal arc test is not a type test of IEC 61439 series. However, it's each time more required by the users, that equipment has this ability of supporting the internal arcs. But for medium voltage switchgear, it is a type test, fully included in the standard. In this case, then it's not type test, but many users request them. The ways of doing the tests are more or less similar to the one performed in medium voltage switchgear, and we can see many details of this in chapter 9 of this training. And in the case of low voltage assemblies, the basic test is the same, but in this case we don't install in the around the switchgear some horizontal deflectors included, in which it will be installed some cotton indicators to simulate the skin of a person, which could be in the neighborhood of the switchgear. But as a general approach, the criteria for passing on the test and the basic test is basically the same. About internal arc classification and criteria for a low voltage switchgear, we have some small difference to the medium voltage IC standards. Here in TR 61641, there are 3 levels of classification. The first one is when the equipment is able to have the protection to persons. Then to pass in this kind of classification, you need to do a test, and in this test, the criteria for approval is that the doors should not open, you cannot throw parts and pieces outside the switchgear, you may have no holes in the outer parts of the switchgear. Through these rows we could have the exit of hot gases. We cannot burn the vertical indicators, and the protective circuit of accessible parts shall be effective after the test. This is basically the same criteria for the classification of medium voltage switchgear. The only difference here is that in the medium voltage switchgear you put the vertical indicators as we have in low voltage switchgear, but there are also some horizontal indicators at the height of the head of one person that could be placed outside the switchgear. And that is interesting because most of the tests for AIS equipment in medium voltage in which we have failures, that is, the equipment do not pass the test, is exactly because the horizontal indicators are not made of cotton, are not burned. But in low voltage switchgear, they are not present in the test. There is a second classification for low voltage switchgear, respect to internal arc classification, which is the protection to person and to the equipment. And in this case, you must attend the conditions of protection of persons that I mentioned before, but also the arc should be restricted to the ignition area and cannot propagate to other compartments. This is an important difference, and if you have this classification, it's a little bit more severe than the first one alone. And there is still one additional classification, which is possible if the manufacturer wants to be able to do this, which is the the classification in which the equipment after the arc is able to operate in a limited way. To operate in a limited way means the following. You need to attend all the criteria that I mentioned above for the internal arc classification A and B above, but also after the internal arc test, we should do a dielectric test at 1.5 the rated voltage during 1 minute, and the equipment should pass on the test. This means that during this direct test, that the equipment is still in a reasonable condition for operating during a small period while we are repairing the other areas of the switchgear. And that is it. Here, there is an important point related to internal arc test, which is about the ignition points of the arc. The standard mentions 6 possible positions that we can see them well in this diagram in the middle of the slide, which are the load side of a feeder, supply side of a feeder, along distribution bars, along main bus bars, load side of an incoming functional unit, supply side of an incoming functional unit. Let's say you can, when the user or the manufacturer is doing the test, he is able to ask to the laboratory to do the tests with these ignition points. A very important point is that the manufacturer is not obliged to doing all these points if they are applicable to you. The manufacturer decides in which points he wants that to do internal arc applications to register in the test report. There are some laboratories that sometimes say, no, you have to do all of them. This is not correct according to the standard. The standard only indicates the possible points, and the choice for doing in 1, 2, 3 or all is of the manufacturer. It's an important point to remember. Then we arrive to the last slide of this presentation, and just as final comments, remembering some points that we mentioned in the previous slide, IEC 62149 brought very important advances with the concept of design rules because avoid tests. The weak point of this good IEC document is the fact that the maximum permitted temperature rise in the temperature rise tests are not well defined as should be. This is a source of confusions all over the world. It's easy to correct, but by some reason, up to today, it's not correct. As temperature rise is the most important aspect defining the aging of equipment, we suggest to read carefully the article, which IEC 6149, the mystery of temperature rise limits. In the section publication of Cognitor site, you may download this article there, and the link for this is on some of the slides before of this free article. And then I thank you all very much for the attention and hope to see you again in some other chapter of this training. Then we arrived to the last slide of this presentation, and we thank you very much for your attention, and we hope to see you again in the next video class of this training. Thank you very much.